Hey guys, in this video we are going to learn about heap or priority queue. So heap is another one of our advanced data structures and it is also called as priority queue. So priority queue, as the name suggests, is very similar to a general queue. Okay, so a general queue or the queue which we have been using until now worked on the principle of first in, first out. So if I inserted 4 elements in the queue 10, 20, 30 and 40, it is a 40. So now if I use the methods provided in the queue, that is for example peek or remove. Okay, so if I used peek, this would actually return me the element which was inserted first. Okay, so initially the element which I inserted first was 10, so it would give me 10. Okay, now if I use the remove method, it will return me 10, but it will remove it from the queue. Okay, so now if I use the peek method again, this would give me 20. Okay, and if I use the remove, it would return me 20 and remove it from the queue. Okay, now the new peak is 30. So what is happening here, it is removing elements using the first in first out method. So the element which was inserted first was removed first. A priority queue is very similar in the sense that it uses the same methods such as add, remove and peek, but the only thing different is that these methods worked a bit different because every element in a priority queue or a heap has a certain priority, and that priority is decided by the type of priority queue that we have made. Okay, so for example, we can have two different types of priority queue. Like for a rank priority queue, lower the rank, higher should be its priority, right? And it would be exact opposite for a priority queue of scores. So higher the score, higher would be the priority. Okay, so let us say for a priority queue for a heap of, let me just quickly make a heap of, let us say, scores. Okay, so let me just insert random numbers here. So I will just write 2, 10, 8, 5 and let us say 16. So let us say for ranks. So for ranks, what we know that lower elements should have higher priority. So if we make a priority queue by default, so by default it would give smallest element as the highest priority. Okay, so this is by default for a integer, for a priority of integer, smallest element would have the highest priority. Okay, so if we use the peek function here, it won't matter which element was inserted first, but the element which is smallest. So in these 5 elements, the smallest one is 2, so it would give me 2. Okay, if I use remove, it would return me 2 and it will remove it from the heap. Now again, if I use the peek function, it will return the smallest element among these 4, so that would be 5, so it would give me 5. And if I use remove, it will return me 5 and the new peak formed is 8. So actually the final output that I would get if I print all those elements one by one after removing, I would get 2, 5, I would get 8, then I would get 10 and then I would get 16. Okay, so what we see here, we have gotten a sorted array. Okay, sorted array of elements. Okay, and this has been sorted in an increasing order because the smallest element had the highest priority. Okay, and we can do the reverse sorting also by using collection sort reverse sorter that I will show in the example that I'm going to discuss. Okay, now what I want to uh, one more thing that I want to say, state is that these three functions, among these three functions, these two work with a time complexity of log n. Okay, and this works with a time complexity of O1. So this should be O log n and this works with O1. Okay, so now we are going to implement a simple priority queue. So let me just write it here. So its declaration is very similar to that of a general queue. So priority queue integer I'm gonna name it PQ. So new priority queue, and I haven't specified anything here. So by default, it will make highest priority. It will give highest priority to smallest element. Okay. By default, it does that. Okay. Now let me make an array. Okay. Let us say random numbers like 5, 1, 7, 19, and let us say 23. Okay. Now if I store them into the priority queue, so I will do that by pq.add. Well, so this had added all the priority queue, all the elements in the priority queue. Now I'm going to print them one by one using pq.remove, and while pq.size is greater than the 0. So what this would do is it would remove elements one by one. So this should be system.out.println print. I'm gonna use pq.remove, and let me specify space here. Now let us see what the output we get. Okay, okay, thank you. Okay, so here I should give. Okay, so as we can see, we have gotten a sorted array in the ascending order. So 1 first, 5, 7, then 19, then 23. So this is how we can sort the elements. So there are two types of heap sort. One is in space heap sort, and this is the next second method by using a priority queue. Okay, so let us now discuss what is the time complexity of this sorting. So as we can see from here, this is, since I stated that the add would have a log n, the add would have a log n time complexity. So this would have a log n time complexity, and since it is running n times, so the overall time complexity will be n log n. Similarly, this would have also time complexity of n log n, because it is removing n elements and running n times, and running in log n time. So the overall time complexity would be O n log n. So this is the time complexity of the heap sort using a priority queue. Okay, so this is how a heap sorting works using this one. Now what I'm going to show is how we actually change the priority system of the priority queue. That is how we give the highest element higher priority. So to do that, what I'm just going to do is specify here collections dot reverse order. So what this would do is actually give highest element, the largest element, the highest priority. So if I do this, it would change this to highest priority to largest element. Okay, so among these five, the largest element 23. So 23 would be printed first, and then 19, and then so on. Let's see. So as you can see, it has sorted it into decreasing order. So 23 is first, then 19, then 7, then 5, and then 1. So this is how we use a priority queue. And if you have learned anything new, please don't forget to like and share the video, and I'll see you guys in the next video. Thank you very much.